Hey there, welcome back to Coding at Home. Okay, welcome back for real this time to Coding at Home. Today we're going to be talking about the Cipher Playground, which is a free playground from Apple that tells a little bit of a story. It's one of my favorites. Let's jump over to the iPad and try it out. All right, so we got the Cipher Playground from the More Playgrounds area. We just hit See All. It's in the challenges area, so I'm actually just going to swipe over this list until I get to Cipher. And then I just hit the Get button to download that playground. So I'm going to open up the one that I've already downloaded. If you're waiting to download it, you might need to pause the video here. So our very first task was we were faced with this page here, and we'll reset it. And there was nothing, if we run our code, nothing actually happens, because what we need to do is we need to follow the comment here. We need to open the book. So when we tap in the source code editor, our autocomplete bar should eventually show us open book. And if it doesn't show it for you, just tap at the end of the comment, tap back down here, and we'll tap open book and we'll run our code. So the story is we're hiding in a library where it's nice and warm and quiet, a relief from the snowstorm outside, which is nearly accurate in Ireland in July. And we're going to learn a little bit about cryptography, which is just the art, as it says here, of encrypting and decrypting messages written in secret code. So we can scroll through this. Once you run the book, you can actually scroll through this text here and read a little bit about what cryptography is and how we've gotten to where we are today. Because now we do a lot of our encrypting and decrypting with computers. In the past, we wouldn't have had computers to encrypt and decrypt messages. Like the Romans had a method for encrypting messages that they didn't want the enemy to read. So once we're done reading about cryptography, we can either hit next page down here or we can hit the next arrow up here. So now we're sitting on the floor of the library. We opened up our book on cryptography. Other people are walking by. We can read about transposition ciphers. So that's a cipher that's encrypted by mixing up or moving all the letters of the original message without changing them. We can read about steganography. So that's where we hide secret text or images inside other more innocent looking text and images. And so now we turn to the substitution ciphers chapter over here. And if we tap on that, we'll see that it's a cipher that's encrypted by substituting a different letter for each original letter. And we're going to see what that means. We're actually going to get to feel it in just a second. So in the pages of this substitution ciphers chapter, we see a small folded up piece of notepaper over here between the pages. So somebody must have used it as a bookmark and forgotten to take it out. And we can read through this if we run our code, as it says here. So now we can scroll through here and we can read a little bit about what a substitution cipher is. So to encrypt a message, we might choose a number from 1 to 26 and shift or move each letter in the message over in the alphabet by that number of places. So in this case, if we have the word bed and we shift it over 3 letters, B becomes E, E becomes H, D becomes G. And then to decrypt the message, we take that value, that 3, that we use to encrypt the message, and then we count backward through the alphabet by that number of letters. So we'd go from E minus 3 letters to B, because each one of these letters we'd give a value from 1 to 26. So if we tap on the note, it's a note, but it looks like it's written in code, because this looks like gibberish to me. So now we have to figure out who left it. Were we supposed to find it? Maybe we can decrypt it to find out. So we can either hit next page down there or the next arrow. So now that we found this note that looks encrypted, we have to try to figure out how we're going to decrypt it. So we just found it in the substitution cipher, so maybe we're going to use that knowledge that we just learned about shifting letters over so many and apply it to this particular message. So we have a blue text here. We can always tap on those blue texts inside Playgrounds, and it tells us that decryption is the process of converting a ciphertext, which is encrypted message, to its original message. So, okay, so we look over here. There are a few cryptographic functions for us to practice with. They've written one for us here called shift. And we can pass in a word, so it's a string, and then we can play around with our shift count. So just like we shifted bed in the previous page, we can try that again, actually. So I'm going to try bed. So this is the first thing we did. Choose a word to encrypt. Maybe you want to try your name. We're going to choose a shift count. Now, if we choose 0, what do you think is going to happen? I'll delete that and put 0 in there. I'm going to run my code, and it's going to get passed into this function here. My word is the first parameter, and then by is the next parameter, shift count. So let's run it. Okay, so it just output bed. Not super interesting. Let's try 3. And let's run our code. Okay, so we can see it processed our message, and it decrypted it, or it encrypted it, sorry, 3 times. So in the third shift, it would be EHG, just like it showed us on the previous page. And you can see that, you know, B goes to C, goes to D, goes to E, and then E gets incremented as well. Now, if we wanted to be really clever, we could say, hey, let's do this 26 times, and then run our code. And we can see this function loops through, and it encrypts bed, and it shows us what it would look like for every single shift. So if I passed you a message that said ZCB, and I said it was 24 was the key, we'd be able to decrypt that message. Now, maybe I was sending that message telling someone to go to bed. I might want to give them a more interesting message than that. But try it out with a few different things. We can try it out with a longer word like kangaroo. 26 is the most interesting because we'll get all the values here for every single shift. All right, so now that's a bit of practice with our shift function. Let's move on to the next page and try to decrypt the message that someone left inside the book. So I'm going to hit the next arrow. So now we practiced a little bit with our shift function that we looked up on the library's computer. What we're going to do is explore brute force a little bit. So if we tap on brute force, it just says a decryption system that uses every possible option to break an encryption scheme. Now, if we're using that same shift strategy that we're using in the previous page, if we run it 26 times, one of those times it'll have decrypted the message, but it means that we have to run it 26 times. And when we're decrypting messages, sometimes you'll hear them talk about attacking it. The cipher is the encrypted message. And if we tap on attack, it'll say just a method used to break an encryption scheme. Sounds maybe a little more exciting than it actually is when you let the computer do your job. And in fact, they compare it to sort of like the time the school janitor was locked out of her office. The janitor had to come with a key ring and try every key to figure out which one opened the door. And we're kind of have to do the same thing to crack this code that was left inside the book. We'll have to try all the different shift values to see if it is actually a substitution cipher. So let's try before. So we have the shifting function from before, all the Swift operators. We're decrypting now. So instead of the letters shifting forward, like when we're encrypting, they'll shift backwards. So now we have to go through these steps here. So we'll figure out how many times we need to call the shift function to check every possibility. So how many times do you think we have to go through this? Well, the 26 letters in the alphabet, we did 26 on the previous page. Let's try 26. So we're going to write the code to call the shift function as many times as we need to. So what kind of code structure helps us do something repetitively? So if we were going to brute force attack this ciphertext, and this ciphertext has the value, has all these letters in it, so we can use that as our variable, like we had the word before. So let's do this. We'll have a for loop, right? So we're going to do this 26 times. To loop through. So when we call the shift function, so now we need to actually write our code that will run in this loop. So down here in the autocomplete bar, we have our shift function. So we'll say, okay, shift. The word is going to be the ciphertext, because that's going to include all of these characters. And now we're going to shift it by a certain number. So let's tap on the placeholder there. And we'll actually use the I value. Right, because the first time through it'll be 1. So it'll shift all these letters over 1. And we'll shift, that'll change, that I will change every single time we loop through this code. So let's see if that's enough. Let's try running our code. Okay, so this is shift 1. We get this. That doesn't look like any message that I understand, so I'm going to go hit next to look at the next one. That's shift 2. That still doesn't look intelligible to me, so let's hit next again. Shift 3, still not intelligible. Shift 4, still not there. Ah, shift 5 is the one that did it. And our message looks like this. Hopefully you can hear me over the noise of our neighbors. So congratulations, Seeker, we've passed the first test. So we found, few if ever find the path and fewer still walk upon it. Look to N to continue your journey. Open sesame. Okay, well that's a bit cryptic itself. So the message is definitely leading us on to somewhere else. So let's click on to the next page. So who is N? The message said look to N. So we glanced around the library. We see all sorts of things that might be N. Novels, notebooks, newspapers, Mr. Nefarian, the library. So if we tap on here, choose what to investigate, we'll see that we get 3 values in the autocomplete bar. So let's try investigating with the newspapers. We'll run our code. All right, so we don't find anything mysterious in the pile of newspapers on the table, just a candy wrapper, okay. Well, let's try Nefarian. If we hit play. Ah, there we go. What kind of name is Mr. Nefarian anyway? Sounds like it came from a video game. So we walk to the reference desk. Let's go to the next page. Okay. So approaching the reference desk, we clear our throat and Mr. Nefarian eyes us suspiciously. Yes, can I help you? Please, do you have the answer, you ask. Mr. Nefarian looks at you blankly. The answer to what? He replies. You're not sure what to do now. He must be N, but he doesn't seem to know anything. Maybe we're forgetting something from the message. So we need to give them a password. What do you think the password is? We run our code. Well, we didn't get anything. Let's look at our hint. What did it say at the end of the decrypted message again? Well, what did it say? You might remember that it said open sesame. So let's change our password to that. And we'll make it all capitals. So we'll double click the shift button, which is down here. We'll do open space sesame. And let's run our code. He looks at us sharply, first surprised and then impressed. He reaches under the counter, hands you an envelope, and with a glance over his shoulder as he walks into the back room, murmurs, "Good luck." Let's hit the next page. So that's it. We finished Cipher. I know this is a bit of an anticlimax. I love that it's got a little story and that we had to kind of tackle a few puzzles to get to the end. But now you can practice sending your own messages to friends by using a little substitution cipher. If we run our code, we're able to type in messages here, change the shift value to something other than 0, because that's not very useful. And we'll change our shift value to maybe, let's do 9, and then run our code. And this would be my secret message of, this is my secret message. So play around with that. Send messages off to your friends. I think this is a great way to get introduced to cryptography. Feel free to, when someone sends you an encrypted messages, feel free to go to the decrypt function and try figuring out which shift they used. Maybe you need to go back to the ciphertext page, back to this page here, cracking the code, and write a loop to loop through your friend's message if they don't give you the shift key. It's really a great primer on encrypting and decrypting your messages. Great place to start up your own secret club and start playing around with all sorts of secret plans that you can't share with anyone else. Maybe this is how you tell your parents that you've done your chores, or ask for a pet or something. But there's a lot of fun to be had in this encryption business. All right, I hope you had fun with us today. Tomorrow, I think we might kick off with a little bit of sensor create, and then we're gonna kind of let you guys explore a bit over the summer on your own. Maybe go back to the everyone can code puzzles material, and get ready for our next big thing in coding. All right, hope you had fun today. Make sure you like and subscribe, and happy coding.